We want to find a third-degree polynomial function f of x with real coefficients -3 and I as zeros such that f of 1 equals 8. So where in the world would we even start? Well, we're going to begin with what we learned about linear factorization. And so what that means is, in this case, we want a third degree. So that means that x has to be raised to the third power. So if we use the formula, that means that f of x equals, we have a sub n times x minus c1 times x minus c2 times x minus c3. So now that's just from the theorem. It still looks very raw. But now what we know is, we know that we have our zeros, right? It provided to us that we have -3 and I. So now how does that fit into what we're looking for? Well, that means that I can change this, or plug in, if you will. I know that one of them is -3, so this would be x plus 3. I also know I have I, so that's going to be x minus I. Now remember, whenever you use I, you have to use the conjugate, which is minus I, so that you have a real coefficient. So this would also be x plus I. So remember, if you have I, you must also have negative I. Okay, so I've got it broken down a little bit more. Now, what we need to do is, we have already found what C1, C2, and C3 are. So where will we go from here? Well, we're going to have to do some multiplication. What does that mean? That means that I need to simplify this x minus I, x plus I. So right here I can simplify this term. And when I do that, I'm going to get a sub n times x plus 3. Now remember, you're going to FOIL this. So you're going to get x squared. It's a plus and a minus, so that term cancels out. And then minus I times positive I is I squared, negative I squared. And so negative I squared is 1. So that's what that factors out to. So this right here, just to make sure we're on the same, I got x squared minus ix plus ix minus I squared. So this is minus times negative 1. So the next step that we need to look at is, what else was given to us in the problem? Well, it told us originally that f of 1 equals 8. So I'm going to go ahead and I'm going to plug in 1 everywhere I see an x. So this would be a sub n times 1 plus 3 times 1 squared plus 1. And that would equal to a sub n times 4 times 2. So that would equal to 8 a sub n. Now we just wrote over here on the side that f of 1 equals 8, so I'm going to plug in the 8 for that. If I solve for a sub n, I'm going to get 1. So here we go. Here's half the battle. We've found out what a sub n is, and we have the equation. Now, which equation am I talking about? I'm talking about this equation right here. This is the one that we simplified it down to. So what I want to do is, in the one I just boxed in pink, I'm going to rewrite that with my coefficient of 1. So I'm going to get f of x equals x plus 3 times x squared plus 1. Now, the instructions said it had to be a third degree. Well, what I have is a third degree, but don't you think it would be easier to identify that it is a third degree if we were to use FOIL on this? So I'm going to go ahead and FOIL this out. So I'm going to get x cubed plus x plus 3x squared plus 3, and then I'm going to rewrite it in decreasing exponential order. So this would be x cubed plus 3x squared plus x plus 3. And so there we go. We found our polynomial function.